Today we're going to discuss about the number I and complex numbers operations. Since you are already in Algebra 2, I would like to start this lesson by introducing to you this flowchart. So in the world of numbers, there are real numbers and imaginary numbers. Under real numbers, you have rational and irrational. An example of irrational are the pi, square root of 2. Rational numbers are integers and fractions. Under integers are whole numbers. So integers are signed whole numbers. But whole numbers starts with 0 and just all positive. Under whole numbers, there are natural numbers, which are the counting numbers. Today, we are going to focus our attention on this part right here, which are the imaginary numbers, which is I. So I is an imaginary number, represents imaginary number, and I is also equal to square root of -1. In this lesson, it is very important for us to derive the different equivalents of I. So let us begin. I to the 0 is equal to 1. And then we said that I to the first power, or I, is equal to square root of -1. For the purposes of our discussion, other than I equals square root of -1, I want you to also remember that I is equal to itself. We will be using that a lot. So I is definitely equal to itself, which is I. Now let us go to I squared. I squared, as you all know, is I times I, which is the same as square root of -1 times square root of -1, which will be square root of -1 squared. And you'll know that when that happens, this radical right here and that exponent right there will cancel each other out, and we will just be left with -1. So now let's go to I to the third. I to the third is really a combination of I to the first times I squared. Let's review this. You learned before that when the bases are the same and you're multiplying them, you can add the exponents. So that's the reason why I to the first times I squared is really I to the third. Okay, so we said that I to the first is just an I. So we put it there. And then I squared is -1. So now multiply them and the answer is -I. For I to the fourth, I will just be using I squared times I squared, which is going to be -1 times -1, which is right there, and the answer to that is 1. So I to the fourth is just equal to 1. Now let's go to I to the fifth, and in my case, I'm using I to the fourth times I to the first. However, you can also try I to the second and I to the third. They will sum up to 5, and we are all going to get the same exact answer. So let's do this. I to the fourth is 1, and I to the first is I, and 1 times I is I. Let's keep on going and do I to the sixth, and I'm just going to use I to the third times I to the third. So right here is your I to the third, and so I will just have a -I times -I. Negative times negative is positive. I times I is I squared. I squared is said to be -1. At this point, I have emphasized a couple of things for you so that you can kind of figure out a pattern. Right here is 1, and then an I. A -1, a -I. 1 again, an I again, a -1. Therefore, our I to the 7 is going to have a -I right here. For our I to the 7th, I am just going to use I to the 4th times I to the 3rd. I to the 4th is 1, I to the 3rd is -I, so 1 times -I is -I. So after deriving all these values of I, we are now going to have some exercises. Keep this handy because you're going to use all these equivalents to be able to solve for some exercises. Sample number 1, solve for I to the power of 120. Now that is a lot to be solving. So what we want to do is to use all these small numbers that we have in order to get to that big number. Notice that 120 is divisible by 4. So I'm going to utilize that and use that 4 since it's also so handy that it is equal to 1. So let's do it. So I hope you still remember your power of powers. If there's a power inside the parentheses and outside, you multiply them, and so 4 times 30 is 120. Why did I choose 4? That is a special number that is just equal to 1, and so that is going to really help me a lot. So now look how simple that is now. So that is I to the 4th, which is just a 1, power of 30. I want you to think about this. If I have 1 times 1 times 1 times 1 30 times, what's the answer? Very good. So the answer here is just a 1. Let's have this next example. Negative 2 times I to the power of 100. Notice that 100 is again divisible by 4. Down to negative 2. Use I to the 4th and powers 25. Again, copy down the negative 2. Put 1 in place of I to the 4th. Power of 25, which 1 to the power of 25 is still a 1. That will just be a negative 2, and this whole thing is just a 1, which is a negative 2. Now let's try this one. 4i to the 63. Copy the 4 here. Okay, now I want to do this slowly for you because this is, something different. What I did was I had split the 63 into a 60 and a 3, and I multiplied them. Again, let's go back to that rule that says if the bases are the same and you're multiplying, then you add the exponents, which is that will sum up to a 63. So let me explain why I did that. I know that 60 is divisible by 4. Okay? So I know that it's 15 times 4. So now I can go ahead and do the power of powers like I did here on the 60. And then just leave it there, leave this there, and use this information to have my value for the I to the 3rd. Let's do it. Copy down the 4. Pressure 60 in terms of I to the 4th, all in parentheses, and then power of 15. Then bring down I to the 3rd. Copy down I to the 4th. This part right here will just be 1 to the power of 15. And then I to the 3rd is a negative I, and then you simplify. And 4 times 1, that whole thing will just be a 1, times negative I is negative 4i. Example number 4, negative 3i to the power of 203. Notice how I have distributed my 200 and my 3. Again, it's multiplied, so the rule says add them, and that adds up to 203. Down negative 3. Interpret your I to the 200 into power of powers, which is I to the 4th, all in parentheses, power of 50, will be the product is 200. Then copy down I to the 3, negative 3. I to the 4th is equal to 1, power of 50. I to the 3rd is negative I. Then we will solve. Negative 3 times 1, that's just a 1, times negative I is positive 3i. So now we're going to proceed to complex numbers operations. So this one is a binomial times a monomial. What you're going to do, guys, is just to distribute this to this term and to that term. 3i times negative 5 is negative 15i. 3i times 2i is 6i squared. Copy down negative 15i. Copy down the 6, and then the I squared will have to be changed to a negative 1. Help us out with our operations. It would be good to put all these codes on the side of your paper. Copy this down. Positive 6 times negative 1 is just a negative 6, and that's the answer. Let us have an example where we have a binomial multiplied by a binomial. For some of you, you might want to resort and use the FOIL method. However, I just want to use distribution method, which is pretty much the same as FOIL. But so for the first step, we're going to distribute the 2 and multiply it with negative 3, which is a negative 6. Then we will multiply the 2 with 5i, which is 10i. We will multiply the I with negative 3, which is negative 3i. Then now we will multiply I with 5i, which will be 5i squared. And then now we are going to combine like terms, so the i's will go together, and we are going to simplify. Copy down negative 6 and combine the i's. Then I minus 3i is 7i. And then the 5i squared is going to turn to 5 parentheses negative 1 because I squared is really negative 1. Up it down negative 6, down 7i, and then positive 5 times negative 1 is just a negative 5. After this step, you're going to combine your constants, which are negative 6 and negative 5. And you get your final answer, negative 11 plus 7i. Our next example is a binomial that's been squared. So how are you going to do this? Is you're going to expand it and you are going to do the same thing, distribution or FOIL. So after you expand it, you're going to distribute. So 4 times 4 is 16, and then 4 times 3i is 12i. Now that you're done with the 4 distributing it to these two terms, you're going to proceed to 3i and you will distribute it to both 4 and 3i. So 3i times 4 is 12i, then 3i times 3i is 9i squared. And then you're going to simplify and combine like terms. Bring down 16 and combine 12i plus 12i. 12i plus 12i is 24i. And then the 9i squared is going to turn to 9 times negative 1 because I squared is negative 1. Down 16, bring down 24i. Positive 9 times negative 1 is negative 9, and you're going to combine positive 16 and negative 9 and making it become 7. Your final answer is 7 plus 24i. Now let's take a look at this last and final example, which is 2 plus 7i times 2 minus 7i. 2 times 2 is 4. 2 times negative 7i is negative 14i. Then now you distribute the 7i to the 2, which is 14i. And then 7i times negative 7i is negative 49i squared. Now we bring down the 4 and we combine the i's. However, if you take a look at this, these are actually inverses. We have a negative 14i plus 14i. Guys, this will turn to 0. Therefore, you will just bring this down. And we have been repeating this over and over again, that I squared is negative 1. So therefore, this is how it's going to look like. You're going to multiply 49 with negative 1, and that would be negative 49. Okay, we need to backtrack a little bit because I actually saw my mistake. I wrote this as positive 49, which cannot be because those are different signs. So therefore, this is supposed to be negative 49i squared. So right here is negative 49 times negative 1 is going to turn to positive 49. So our final answer for this one is 53. We are done with our examples. I hope that you learned a lot on complex numbers operations and the very beautiful number